The human eye responds to only a very narrow section of the electromagnetic spectrum, which we refer to as visible light. There are many sources of visible light, but the most obvious is any hot object, which could be the sun, or an electric light, or a bonfire, for example. Any very hot object will emit visible light. In this experiment, we're passing white light through a prism, a glass prism, and splitting it into its constituent colours. Isaac Newton was the first person to realise that white light was actually a combination of all the colours: red, orange, yellow, green, blue, indigo and violet. And he proved this by using a method similar to this to split the light from the sun into its constituent colours and then recombine them back into white light again. And so you can see here that we have a light source, a prism to split the light where refraction occurs and different wavelengths travel at different speeds, and that means that when we look on this board here, we've split the light into different colours. So here we can see the output from the prism, so the light has been split into its constituent colours, so the full spectrum. So we go from red at this end of the spectrum right through to violet at the other end, and you've got all the colours in between. So the prism has split the light depending on the wavelength, and that appears on the screen in different places. So white light is in fact made up of all these colours, and these are all part of the electromagnetic spectrum, and they're all parts of the electromagnetic spectrum that the eye responds to. The human eye responds to a part of the electromagnetic spectrum we refer to as the visible spectrum. This goes obviously from red, right on the boundary of infrared, right up to violet, right on the boundary of ultraviolet. In this model, hopefully you can see what's going on. So these represent, if I take this away, these lines represent lines of light, rays of light that are entering the human eye. And it's focused by passing it through the lens of the eye, and that refracts the light and makes it focus in. And hopefully, if your eye is working correctly or you've got the right glasses on, it is focused at the back of the eye here on the retina. These are nerves in the body that respond to light and turn light signals into electrochemical signals that can then be sent through to the brain. So this back of the eye is covered in an array of sensors called rods and cones, and they turn those light rays that are focused from the lens into electrochemical signals that then pass down through here, through the optical nerve to the brain. When I turn the lights out, you can see very clearly that the light entering the eye is now focused at the back of the eye on the retina. And that's where the rods and cones are turning the signal into electrochemical signals to send to the brain. The retina in the eye contains 4 key types of nerve endings. One is the rods, which respond to black and white, as we've discussed, but the other 3 are cones, and one responds to blue, one responds to green, and one responds to red, which is why you can see in colour. Some people are colourblind, and in that case some of the cones aren't working correctly. It's very common that people are red-green colourblind, and in that case perhaps the red and the green cones aren't acting correctly, so they can't actually distinguish the colours correctly. If you have an eye test, you might look at one of these colour dot maps and see if you can distinguish numbers or letters, for example. And if you can't, it might suggest that you are colourblind, you're not seeing the red and the green correctly, or perhaps the blue. Photographic film is an example of a detector of visible light. Light falls on the photographic film and a chemical reaction occurs which changes the colour of the film. You can see with this Polaroid film that it's been exposed to light, and then gradually the chemical process changes the colour of the paper until it matches the original photo. A camera works in exactly the same way as the eye, really, is that the light is coming into the camera and we use a lens to focus that light onto the back of the camera. So this lens uses refraction of light to focus the rays back here at the back of the camera. And at the back of the camera, on a modern camera, would have a CCD, which is effectively an electronic sensor that picks up the light and the colours and turns that into electronic signals. In a traditional camera, this was done with photographic film, and you'll see a case of a photographic film with a Polaroid camera in a minute. Once I've turned the lights off, you can see very clearly that the lens is focusing the rays of light back here at the back of the camera, where you would have your sensor, whether it was a film or an electronic sensor at the back. So this digital camera can convert visible light into an electronic signal, which can then be redisplayed or stored. So if we switch it on, you'll see that at the front of the camera is a lens, and that lens focuses the light onto a detector that will be at the back of the camera, back here somewhere. And that can be displayed, so in here it's displayed on this LCD display, and then it can also be stored if you take a picture. So if you were to take a picture, it would store that picture electronically, and you could then recover that later on.